Hello and welcome to this session as part of the buildingSMART International Standard Summit Valencia 2024. Thank you for joining. My name is Laura and I will be your moderator today. Today's session title is Building Sustainability Specification. The speaker for this session are Céline, Nisbet and Artur Tomczak. You can see them on the screen. The session is scheduled to last 90 minutes, including time for question at the end. The session is being recorded and will be made available in the replay session of the event as soon as possible. Before I hand over to the speaker, I would like to remind you that this is a hybrid event. For online attendee, your microphone will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendee here in the room, please keep the background noise to a minimum, and if you wish to make comments or ask questions, please raise your hand or use a microphone. I would like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent and standards that are developed do not favor any particular provider and are open, non-binding and accessible to all. Please take note of our antitrust of conduct.
Hello everyone, welcome to this sustainability session. It's the first official sustainability session of the summit with the theme of sustainability. Today, Nick, Artur and myself will present the work that's been done by the Strategic Group for Sustainability. It's a volunteer group of members of this community. And it's, I think, a really nice group because we all do this from a great passion for sustainability. I will try to keep it short with an introduction, after which we can go really straight into the technical details. We will present to you one of the solutions that we think might be very helpful for the industry to work with sustainability assessments. But we also want to discuss with you all 7 or 8, I think, key challenges that we have found and still are working on finding solutions. We have already some proposals, but we would like to discuss with you if you think these are feasible. And then I have to tell you that after this session, if you're interested in the topic of energy analysis, there will be a very, I guess, fun deep dive, a collaboration between some of the members of this group and the building domain. So from 11 to 12:30. But then I also have to say, if you're registered for an exam of PCERT at 11 o'clock, you have to go there. And there will be also a very interesting session on what is it, data consistency by Artur. So it's going to be a tough choice. So this group was initiated exactly a year ago. It was announced at our summit in Rome in March 2023. And since then, we've gathered a couple of experts from our different domains. And later, after we presented our first ideas and findings in Lillestrøm, other experts from outside of the domains joined us. We weren't really sure from the start what we were going to do, but we agreed on one thing, I think, on the beginning, is that we wanted to create something that's useful immediately. So no extensive research or report on what the ideal world would look like. We thought that there were some urgent issues that we could help in solving. And the most pressing were around carbon reporting and life cycle assessment. So we wanted to focus on that. And we had some assumptions, but we wanted to validate them. So we've invited guests from product manufacturing industry, environmental product data, database owners. We've talked to people who are developing software solutions for life cycle assessments. And we just started to put everything together in a document. This document is not really for publication purposes, but we just put all our findings in there, and later we want to translate them into very useful and snappy kind of presentations that we can publish everywhere and that people can use to help them with sustainability assessments. So after all these case studies that we got presented from these users, we could validate some of our problem statements. So I will take you through them. First one, there seems to be a lack of robust solutions for sustainability assessment. And everything I'm talking about now is, of course, around the topic of interoperability and BIM. We saw that there were integration hurdles for interoperable solutions. Then there are solutions out there, but there was low awareness of it. Poor BIM quality obviously doesn't help with sustainability assessment. And we also found that there's insufficient standardization available with regards to sustainability assessments. So we decided we're gonna first start with identifying all those gaps and challenges that exist amongst users. We're gonna have to showcase the effectiveness of Open BIM. So we need to produce really good guidance on how you use our standards and solutions in sustainability assessments. We will probably find some faults, some errors within our available services and standards. So we want to propose improvements to them. And of course, we have to align and collaborate with institutions that set sustainability standards and regulatory schemes. We wanted to keep the scope very tangible, so really focus initially on things that relate directly, that can be found almost always in BIM models. And I know the scope of sustainability is extremely broad and all those topics are relevant, but we decided to start with first embedded resource assessments. You're probably all familiar with assessments of maintenance work on built assets, resource consumption and generation, so really related obviously to energy of buildings, and also water, I believe, yes. And finally have a go at the topic of circularity and waste. The target groups are listed here, but it's pretty much the entire industry we want to provide solutions for. And maybe one of the most important target groups here is obviously the designers and engineers. And that first group, designers, is not very widely represented in this community, but we're lucky to have one architect, at least in our sustainability group, and I see someone else who wants to join, so that's great. We of course try to partner with relevant organizations that work in this field. There we go. So I have to give a big compliment to Nisbet. He has been working in weekends, in nights on one of the first solutions that we thought would be for sure helpful with sustainability assessment, and it would be also nice to use one of our newest standards with that. And that is an IDS solution for sustainability assessment. And Nick will take you through it.
Thank you. A year ago in Rome, I proposed that the group should get working and try and deliver something in a year. Now, given that it's taken 24 years to deliver the IFC schema, we knew that was going to be ambitious. And we also knew that we had to think about the industry in lots of different angles and different perspectives, as Céline's listed. And we had to try and come up with something which would help the industry work together throughout the life cycle of projects and throughout the life cycle of the built assets. And following the recommended buildingSMART process, we started with a very simple flow diagram, a swim lane diagram, thinking about who does what, and identifying some of the key actors and the key exchanges that take place. And at the top, we have a swim lane that is labeled architect, engineer, or surveyor, because we wanted a solution that was applicable to buildings and to infrastructure and to existing buildings, so that we could, as I say, span the whole life cycle. And the important thing about those three roles is that they describe the facility. Now, my background a long time ago is an architect, so I may say building, but I want you to hear facility, because everything we're trying to do should work for any kind of built asset. And their job is to describe the facility, and that's labeled A. And also part of that job is to describe and specify the types of the products or materials that they are seeing. However, in some processes, that job of step B is also performed by a specifier or an estimator, perhaps. And so the work is split between those two roles. So step B appears twice on the diagram. And then in general, the next step in a sustainability assessment is then to find the eco data, whatever the measures are. So step C is then to match the declarations up against the products that you've identified in the building, or materials, or whatever. And that may be done by that specifier, or you may have an expert, an assessor, who will make that second link. But in doing all that, you're collecting information, and across the bottom, I've just represented an idealized assessment scheme of taking the quantity, the measurements from the facility, relating it to the products, and then relating it to the declarations to get an outcome. Now, there are plenty of examples. A PhD student sent me 105 different metrics that have been published about on sustainability. I think we've been thinking about 15 different assessment schemes. And we're trying to stand back from all those and say, what is the general pattern? And we know that in Europe, there's a certain scheme. In the UK, we have a certain scheme. In the US and in Canada, there are schemes and so on. And we're trying to stand back from the actual assessment scheme and say, what does the industry have to provide as information for any of those schemes to work? Just as an example, I had a 2-hour conversation with someone who wanted to talk about social sustainability, and in particular, the noise from building sites. We can't do every kind of sustainability in this first go. So our focus is really on environmental sustainability. And yeah, we can think about some of these more unusual metrics another time. So that's our process. And what we wanted to bring to that was the IDS. Now, some of you will be very comfortable with what the IDS is. But I'd like to say a little bit about it. A key part of any process is information requirements of specifying what should be delivered. And if you're following ISO 19650, you will be thinking about asset information requirements and under contracts, exchange information requirements. What the IDS does is to say that those requirements can be captured in a form that is readable by a human being, or can be, sorry, I should say, it can be presented as a human readable document that can be attached to a contract or attached to an execution plan. But more importantly, it can be read by a machine. And that means that we can have a specification for deciding if an information deliverable is meeting the expectations. And I think the key idea that comes out of the work we've done for the last year is that we come to the detail of that. I think one of the interesting things about, well, one of the useful things about IDS is that they remain accessible and you can improve them. And so we have to expect that different locales, different chapters, different organizations will tailor what we're offering to the local situation. Some assessment schemes pay attention to only the embedded resources in carbon. Some don't take circularity into account and so on. So we're trying to offer a full menu, but we know that people will edit the IDSs to their particular situation. We also know that different parts of the world have got different classification systems. In some sectors, it's very important. In others, the industry seems to manage without classification systems at all. So we're trying to be neutral about that. And just as a really basic example, we put into our rules that we don't want to apply the information requirements to objects smaller than 1/10 of a cubic meter. Now that's just a guess, but obviously we don't want people to be adding information into a facility model about nuts, bolts, screws, whatever it happens to be. So we think there should be a cutoff. And I had a conversation yesterday with someone from the rail sector, and he said 0.1 of a cubic meter is exactly right, because that's just smaller than a railway sleeper. So I thought, it was a good guess. So we put that rule in, but people might want to change it up or down. If you're doing a large infrastructure project, you might take a higher value. So we know that what we produce as an IDS can be customized. And I think we know that the industry has got to learn a lot, still learning about information quality. The issue of poor quality information in BIM models is because there's poor checking. And if there's poor checking, then things don't go better. And one of the roles of the IDS will be to help people make better models. So that's what we're using the IDS for. We want it to be used at any stage in the life cycle. You can use it when looking at buildings in use or as found, and you may be assuming what products and types you're looking at. We want to use it in early stage of a project using generic types, and then of course later in the specification cycle, we expect there will be specific products from named manufacturers and model numbers and that kind of thing. We want it to be applicable to buildings and infrastructure and plant, and there's probably a few other things I should list there, but across all kinds of built assets that the buildingSMART schemes now address. And there are some things we can't legislate for in the IDS. It will still be up to the user to make sure that their models are complete and consistent for the stage of work that they're at. And of course, they remain responsible for, or they have to make their own choices about the assessment methodology that's going to be used. So buildingSMART is trying to offer, with the IDS, a benchmark to say this is sufficiently complete across all those different purposes. We saw the scope diagram earlier, and I just thought I would lay it against a diagram from the European standard. The first scope is committed or embedded or capital resources, if you're thinking about money. The second scope looks at the cyclical maintenance and replacement cycles for a built asset. The third scope is those continuing resource usage, energy and water, P6 and B7 in the European scheme. And then there is what they label stage D, looking at recycling and repurposing and so on. And we felt that if we could match those, then we would have a good coverage of the whole life cycle assessment, even if in particular locales some of it is not implemented or not used much. So that's our scope. The biggest insight that I hope you'll go away with today is actually going back to the process diagram. There are three separate problems. There is what information should be in the facility model, the building model, about its location, about what it's comprised of, and if it is a building, the spaces it's containing. There is a second information requirement, which is considering any particular product or type or material, what information should be attached to that product. And then the third information requirement is what should be in a declaration. And yes, we know there's an ISO standard for EPDs, but other aspects may come in, and there may be other, like my social example of the noise from building sites, there may be other measures that we start to look for in order to make those kind of assessments. So in fact, we have developed three separate IDSs. Each of them is applicable throughout the life cycle, but it's not necessarily the duty of the engineer or the architect to check all those three. He can take the facility IDS and say, I will see if my my model is sufficiently complete. So that's an important idea, and they can keep checking throughout the working cycle they're going through. Many people have the idea that a facility model has to have everything in it. And I think we need to allow for that if it happens, and in which case you would check your facility model with all three IDS files. But it's more realistic to think that perhaps you'll only have facility and product information, and the declarations will be stored elsewhere. Or looking at the bottom line, of course, all three could be stored in different places. And in the terminology of ISO 19650, we would call that a federated approach. We're not expecting all the information to be in one place, but we are expecting it to be consistent and linkable across. So it's very much the case that we want people to use the three IDSs, each of the ones that are appropriate to their role in the process. The way we did this is, of course, we made a spreadsheet. I loathe spreadsheets. But somehow, when we're tackling an information problem, it always comes down to thinking through the problem on a spreadsheet. And this is a snapshot. And it shows that we have the 4 use cases highlighted in orange. We didn't document in the order 1, 2, 3, 4, which is funny, but we also introduced a general thing at the top, basic information about the, in this case, the facility. And then the way that the IDS works is that you define the applicability of, you're going to make a specification, a rule, and you list all the things about the applicability, and then you list all the requirements that you want enforced for that particular applicability. So, that's how we laid it out, and we were sufficiently neat about this that we can then generate the IDS documentation from it. And we have 3 spreadsheets, one for the facility, one for product data, and one for declarations. That's what an IDS looks like in raw form. And I hope you're all horrified and disgusted, because that's what technology does to information. It structures it in such a way as to frighten everyone. But the good news is that IDSs can be presented in lots of different ways. There is a standard called ISO 12911 that helps present rules, and this is generated automatically from the IDS. And at the top, you can see that it's the facility IDS, and again, it's following this pattern of each of the use cases. You can also use many of the online tools, and so this is an example from ACCA, isn't it? Yes. So ACCA software helps you prepare IDSs and will generate an annex that you can attach to a contract or an award or an agreement, generated directly from the IDS file. And we can see at the top that this is covering IFC 4X3, and it starts off by saying there must be a site entity in your facility model, and it must have an address and the reference latitude and longitude, and so on. And of course, that's important to identify what jurisdiction you're in. It's important to identify transport costs, and so on and so forth. And then it goes on and looks at the individual use cases for a page or two, and so on. So the IDS is both something that can be reviewed by senior people to say, are we going to try and achieve this? By management people to say, what do we need to put in place in our BIM processes to deliver this? And of course, it can be presented to designers to make sure that they understand it and follow it. And it can be checked automatically. Going to run through a really, really simple example. It's, again, I think it might be so simple you'll be horrified. But I am having an extension built on my house. And on the top corner, you can see what my house really looks like. But I thought I would simplify it for the purposes of this example. And you can see that the extension I'm planning to build is an upper floor extension on the side of the house. The block at the front is the garage. The bit underneath the highlighted object is the study, and anyone who has done video calls with me will know that that end of the building is sinking under the weight of books in my study. So part of the work is going to be to shore up the foundations. So very simple model, 5, 6 objects. And the question I wanted to answer was, what is the embedded carbon impacts of my new extension. So I made a model and I complied with the facility IDS, and you can see, well, you can't see, but the parameters listed there are the ones that includes the ones that are required by the facility IDS. I then went looking. I broke this down that the main body of the house was built in 1970. The first extension was built in 1980, and of course the new one, 2024, if my architect gets on with doing the work. And that's the clue, because that's the specification of each bit of the house. It's specified by the year that it was made. And so what I needed to find was information about construction in 1970, construction in 1980, and construction standards now. So here's the facility information, each of the blocks, and I've highlighted extension number 2, which is the one that I'm envisaging, and the information that we needed. Some classification information using, in my case, Uniclass. Manufacturer. Well, of course, I don't have a manufacturer for the whole thing. It's a generic manufacturer, but the model or type specification is construction in 2024. It's got a volume of about 38 cubic meters. And importantly, it's labeled as being new. One of the important things, we need to make sure we start labeling our models with existing and new and all the other options. And that's the core of the information requirement for the facility. I then set up a small product database, which is a type 3, and it's a classification of residential buildings. Again, it's generic, there's no particular. And the only piece of information that I really want from the product data is that the smallest unit of interest is a cubic meter. And the validity in terms of dates, the last changes to the UK building regulations were 2022, the next ones are 2026. So if I can find data in that range, then it'll probably be appropriate to my building. And then the third thing was to find some declaration information. And what is the carbon content for the global warming potential total for stage A in its CO2 equivalent? And luckily, I receive an architectural journal, and every time they publish a domestic building, they give you the carbon content. So all I had to do was to make a record that said, from the examples in architectural journal, I can say that typically 100 cubic meters of domestic construction has an impact of 16,000 kilograms. So that's a piece of declaration information that I just got out of a journal. So you don't have to go to an EPD database and sign up and subscribe. No, it's just out there in this case. And that meant that my 3 pieces of information, my facility model had enough information in it, my product data, which is, or type data, had sufficient to match it to this record of declaration information. And yes, I did a sum, and it's a very simple sum, and I now have the carbon assessment for my extension. 6.5 tons carbon equivalent. So clearly I will need to plant some trees in my garden to compensate. So what we're trying to do is to say that we can consistently apply that to generic objects like I've done, or when I get the specification from the architect next week, I will then have specific products that I can pin down and do another calculation. And no doubt it'll get me a refined figure. but it's the same IDS that I will use to check the block model, as to check the design model. It's the same IDS that I will use to check the product data and the declaration data I'm using. So we have a mechanism for helping the industry track environmental impacts throughout the design cycle, throughout the life cycles, without saying you need a special IDS for detailed design, or you need a special IDS for the contractor's version of what they've done, or the as-built, or whatever. It's one IDS that can keep looking at the model and saying, to reassess this, have we got enough information? So that's the vision. What we will be doing is publishing a guide and these 3 IDS documents. There is a small hold-up, which is IDS isn't going to be approved at version 1 for another month yet, due to all the processes we have to go through. So we will get it out there as soon as the IDS standard is finalized. And then that will be a resource for the industry to use, to test, to criticize, to improve on. But that was the approach we took. And now Artur is going to talk about all the reasons why what we did isn't completely perfect.
Yes, it's thanks Nick for this introduction and the presentation. And as you can see, yeah. It's an enormous work of Nick, but also the whole group. And it looks probably a bit simpler on this example because we made up some of the data and we could, of course, make something that is clear and visible, but we tried to confront it with the practice, and we faced many challenges that we were discussing for weeks, for months sometimes, and we thought it would be a waste if we didn't show those challenges that we faced and some of the solutions we proposed to you. I think for some challenges, we are still trying to figure out the best answer, so we would like to also welcome you to ask questions, provide feedback, share your opinion. So we'll have a microphone, so yes, thanks, Laura. Laura will give you a microphone. And before we have open questions, we prepared those 8 challenges that we faced from the beginning of this working group. So to start with, the first problem was that IFC already had properties, standardized properties for capturing the environmental impacts, but they are not matching the properties that the industry is using because the IFC standard and the ISO standard about LCA were not coordinated. So we have different names for almost the same properties. And a good example is in IFC, we have a property called climate change, and the industry is using global warming potential. So even though they were made to store the same information, they are not the same, and people are confused which one they should use. And because we thought that it's best to align with other industries as well, which already use the global warming potential, all of this terminology from the ISO standard was published, coordinated by Hansueli, and it was published in BSDD so that we, from now on, recommend using those properties that are used in all the industries. And we will make a comment to improve the IFC properties in the future, or maybe deprecate them and suggest using what the LCA standard is suggesting, because we didn't want to force everyone to use something that is only limited to construction industry if they already have other standards for that. So that was our first challenge. How do we call those properties and which properties should we use? And are there any comments, opinions on this approach? Yes, there are 2. Great start.
So thank you very much, first of all, to all of you. So when Céline mentioned it was first not so clear to us what we would like to achieve. Then when I saw what Nick presented, it was so obvious that it's not so easy to define all the goals. I would like to suggest one maybe more simple approach, because what you, Artur, mentioned is now typical. So different authoring tools, different databases have the same property, but maybe just simple example in a different property set. My strong suggestion, this is maybe third time I'm saying this, is why do not enforce uniqueness of property name? And because just let's say there is a carbon footprint, maybe in a product database it's in one property set, maybe in a Revit in another, in ArchiCAD in third, in TechLine in fourth. And why in a formula now, formally I need to write, oh, if it's Tekla, then it's property set dot property name. If it's here, then property set dot property name. Why do not, and let's say that's what we do from the scratch in Bexel. We try to suggest do not have this complex, and essentially now when you have a third database, you know, if data is there, use it. Do not enforce them to change to another property set or somewhere else. So keep it simple and make it much more flexible. That's my suggestion.
Thank you.
What's your opinion about this?
I'm just a messenger. I'm just a messenger of the group here. But yeah, we face exactly the same problem. But what I understand, you're suggesting that we should allow each software to have its own property and each project to have its own.
I suggest, and it's in, if I understood last event in Oslo, we discussed about IFC5. We talked that property in the IFC5 could be changed to any property set. So it's not just bind it to a specific property set. My idea is to have carbon footprint, find it in any property related to element or family or entity, and use it, because it would be much more simple to use this as a formula than if you strictly focus also on the property set dot uniqueness. So achieve or enforce uniqueness of property name at the element level or family level or so on. So that's my idea. Not to do anything manual. So I would like to hear what's your opinion, because that would simplify the entire calculation process, not just for this, but all material takeoffs and so on.
Thank you. One comment. I think the problem is that it is unified, but it's unified in two different standards. One that came from the construction industry, the IFC standard, and the one that was developed in parallel, like not coordinated with our standard, and they came up with different names. So now the challenge is which one should we use, which one we should suggest to the people to follow. And we decided to improve our standard and match with what other industries like automotive, this ISO standard is used throughout all of the sectors. So we decided, okay, let's align with all the industries, and we propose those properties in a form of IDS and a dictionary in BSDD that we are publishing. So I think this is our answer to this, our solution to that. I see there was a question. Yes, thank you. You wanted to add?
Hello. Okay, thank you for the presentation so far. Just a comment regarding the CO2 footprint and the source of data. You were referring that using the publications and information out there. But I think thinking on the future, I think it should be quite important to be more precise, because global warming potential of any product, right, at least in environmental product declaration today, is normalized. So we have basically two norms in the world, the ISO and the EN and the European norm. They have some nuances that are important. So in some way, it may be important to know exactly which of the methodologies are used in the topic. Second, we need to acknowledge that the different industries are decarbonizing, their processes. Whatever manufacturer is decarbonizing up to a certain point, up to a certain year. And in global warming potential, you have basically two types of global warming potential, right? let's say, two values, the gross value and the net value. And today they are basically the same. But as the industry is decarbonizing, these numbers are different. And the net value is, for example, is the one that in reality is impacting the CO2 that is going to the atmosphere. There are certain regulations that are putting a threshold. Like, for example, in France, there is now a maximum CO2 per square meter if you build a new house, etc. And those thresholds are going down, down, down. But if you are using the incorrect value, you may say, this new building, this new house is not complying with the new regulation, because you are using, I don't know, maybe any of these two. So my point here is that even only if you have climate change, global warming potential with the SDG matching, it may be not sufficient for future use of this information. If you don't be more specific, if we are not more specific on certain parameters, so perhaps you need more than only one value or one parameter to complete the right number.
That's one of the next challenges we have on this slide, but thank you so much, Nick.
And I think the role of the work we're doing is the information availability. We are not recommending getting figures from journals like I did for my little example. And we're not saying it has to be an official database as approved by the EU or the national sector. We are not choosing a method. What we're doing is making sure that the industry can have the information it needs to apply this method or that method. It's very competitive. I discovered that the UK has implemented a version of the European standard that hasn't been published yet. And so they say our system is better than things. I've had phone calls at the stupid hours of the night from people telling me what the right methodology should be, and so on. We are not choosing. The quality question of the sources of the information is about the nature of the scheme you're applying, whether it's informal, like my little example, or whether it's strict according to a government regulation or whatever. That will affect where you get your declaration information from. But it doesn't change the fact that you need to go through that three-stage process. So, yeah, I'm not European anymore. And I really appreciate all the things that have being done in Europe, but it's not buildingSMART's role to choose the assessment scheme. Okay.
I would like to just add to that the example you gave, that in France they need to calculate LCA per square meter. I think what we are trying to also do is to say, okay, you need square meters, but how do you calculate the area? Are you sure that you are using, for example, the gross area and somebody else is doing the same? Maybe they exclude the openings and you have a different number. So we try to make sure that people speak the same language, they use the same terminology, and if they are not using the same, they need to be explicit and say, my area is not your area, because we have different standards. So that's what we are trying to achieve also with these ideas, to make people aware of what terminology they are using. In the meantime, there was a question on the chat, if ideas will be available on the buildingSMART website. Yes, it will.
I want to return to Staple's suggestion. We have a risk then that we will end up with first come, first served. Means someone will try to resolve that property name or classification will be able to be, and everyone will be risky to try to bring a property first, but we will end up in where I think it's understood that you need to have a unique thing for some property. If we
Thanks. Yeah.
It will definitely end up in that way. That's what I'm telling. Instead, try to suggest that you have relations in BSTD. First, check what's in IFC, the dictionary, IFC dictionary in BSTD. If you don't find that property in IFC schema, then you create the new one and link it to related ones in other domains of the dictionaries and plus to first one.
Yeah. Thank you, Mirbek. Well, you are partially, like, I agree with you, but also, as Nick said in one of his slides, we are not trying to impose the only set possible, but we allow people to tweak these ideas to their needs. But we want to show them how they can already benefit from that, how they can structure the requirements in the form of ideas. And if they have, for example, local regulations that say it has to be called differently, they can simply just modify this one line of ideas, but they can still reuse the whole body of the requirements. In BSDD, yeah, this is the standard terminology, right?
Okay. Maybe one thing I should have said about the IDS is that any information requirement that you put into the IDS can be keyed back to the BSDD. So you will see a requirement for the net volume on things. That is linked back to the full description in the BSDD. So you'll get the history, you'll get the notes, you'll get the best practice from the BSDD. So it's an example of the way that we are able to join up the buildingSMART standards to make a complete system.
Maybe let's move to the next challenge, because I think we will overlap with those that we have already also identified. So the second one was, how do we split the IDS? Do we do one IDS file for all of the use cases, for all of the needs, or do we split it into facility product declaration, or should we split it per project phase? And this already was described by Nick, that we decided to make 3 IDS files, one for facility, one for product, one for declaration. And depending on the project needs, people can basically apply all of them separately, mix, join together. But our solution was to just provide one IDS for the whole facility or building, and people can decide which information they need at which stage. So if at conceptual stage they don't need to have a reference to actual product declaration, they can just remove that line. But we decided to put it there because we wanted to cover the whole spectrum of properties, right? Are there different approaches to this that you would like to discuss? Yeah.
Yeah. So actually, that answered partially my question. So my strong suggestion: we are involved in several this horizon now. Nick, you're still European. You're not just in European Union. So hopefully you'll go back. But I just wanted to say on a lot of these horizon projects, we have to deliver in a certain time frame results. So we cannot. So my suggestion, and that's part of this, and I like really that you had these 3 IDS, is to can you maybe develop, or maybe it's answered in the following slides, a roadmap, and then also prioritize the things, because I would strongly suggest, in order to do because we understand that the tools cannot generate all the information we need now. Some of them, in an ideal scenario, can, but we work on a different markets. You see a lot of data is missing, and people want to see results. So the suggestion is, can you prioritize the things like what you said with the 0.1? That's a good point. I wanted to say, based on our statistics, it's almost 50% of the elements is removed or more with 0.1. Sometimes 90-80% of all elements is removed, which is okay. But just based on, we did this for other analysis. But just wanted to suggest, can you maybe in an implementation stage, because it's the main goal is that it start be implemented as soon as possible, to have a priorities and said that certain properties to minimize the subsets in order to achieve as soon as possible results, and then maybe say, okay, in the next phase, we will add more and require more. So to have this step-by-step implementation, not to afraid the market and not to achieve clear benefits as soon as possible. And just to answer to Mirvek, maybe we will talk, it's a long discussion. My idea was completely opposite, to allow flexibility and usage, not to make it more complicated. But we'll talk about this. Okay, thank you.
We have phased the implementation with, when we discussed the scope, we said that our first priority is the embedded carbon calculation, or embedded resources calculation. We joined onto that the information that you need for circularity, because it's very similar. We then said that for the maintenance and replacement cycles, yes, you will then need more information in the facility model, you will need more information in the product data. And so at that, for that step, you then need to have information about the environmental conditions that things are operating in, whether they will degrade quickly or slowly, whether their service life will be longer or shorter than expected. When it comes to the assessment of the energy and water in use, then of course with buildings, we look at Mirvek and the work that he's been doing for building energy modeling and saying they're going to produce an IDS which will cover the information that's needed for typical energy simulation and so on. What we say is that we want the results, because for LCA, you want the energy demand profile, and so on. So we have broken it down, saying that the first use case is the embedded assessments, and perhaps the most challenging is the energy and water in use. So that's the ladder that the industry is on. So we have provided for the industry to grow into those four aspects of LCA.
Let's go to the challenge number 3, which was, yes, sure.
Could you explain the difference between a product and declaration?
Yes, we can. Nick, can you?
Yeah, I think we can. In some circumstances, the manufacturer is responsible for declarations. And so you could say they're very close. And that was one of the options that was on my diagram. In other situations, you have to use generic information.
Okay, clear.
And then you will get different links and so on. And you can say that we have a generic product and we need to find something that's a close match, but not an exact match.
Okay, so product the value of product could come from a national standard or national databases, for example.
So it's, and it's useful to do it in those 3 steps, because when you consider product, you can consider what units you want to buy it in and what units it's supplied in, and whether it comes in packets of 3,000 things, or all those differently comes from the product information level. The declaration is usually about a unit-based rate and so on. So it's a very powerful division, although I appreciate that with specific manufacturers, specific products, they provide an information sheet which spans both.
Okay, I personally agree with this setting.
And as also Nick said before, even though sometimes it can be one file, one model, or one database containing both the designed building, all of the product types and declarations embedded inside, sometimes those are 3 separate pieces. You have a generic model, you have a product types from the manufacturer, and you have declarations coming from a separate database. So that's why we have a distinction here.
Are you also thinking about declaring the source of the information? So if its product could be calculated by the designer, calculated by some of other product or some of other declarations.
Yes, one of the rows in the Excel. I know it was not visible because it was just a sample of the full specification, but one of the rows was the reference to the actual document where you took it from. So yeah, we don't say that you should always just copy paste all of the values and just forget the source, but the most important is how did you end up with this number, right?
Yes, thank you. In addition to that, I think to break down the complexity of multiple EPDs of every product, it can make sense that associations, manufacturers, or governments aggregate them to components, complete walls or doors and so on. And then it's much more easier to apply this information in early planning stages. And you can also then reduce the indicators to the most important ones, and from there on make multiple.
Yeah, I will skip to the fourth challenge because that's really related.
Valuable. Yeah. But if there are questions about how would be the first step, early planning stages, let's try to come from one side with the components, and then the architect has more simplicity.
Thank you, Hans-Uli. Well, yes, you were also one of the most active participants in the group, so you know we struggled with this. How do we match the product that we have in the IFC model, and how do we match it with the actual product declaration? Because sometimes they are not so easily distinguished. For example, in IFC, we often have a composite product that is in fact made from products coming from different manufacturers, like a wall with insulation. In IFC, that's usually one element that has one volume, even though it has layers inside. But we don't have, usually we don't pay that much attention in how do we put all of this information in the model. And this was one of the challenges, and the proposed solution to this particular one was that if we have an element that is a composite element, we should put the identifiers in as a sum for all of those layers in a type of this element in the model. Even though we know it's challenging in some software solutions, but we thought this is the best way to capture the product information in a consistent way, because splitting into material constituents, like let's say concrete and reinforcement, is sometimes really difficult because you don't want to model every tiny constituent in a composite element. So that was one of the main challenges, and this is our proposed solution. I saw two hands raised. Bertrand?
On the previous
one.
slide, yeah. Yes. Between the facility and the products, isn't there some room for, I don't know the exact English term, but to slice the facility in lots or package, like the civil work, the openings, the electrical staff, all this, because many directives today already give some lump value per, I know for electrical domain, they say, if you don't have anything, you give it this number of CO2 per square meter. And doesn't it make sense to give ideas for this?
Yes, you can apply the method at the level of a whole system, like an electrical system. But I think and yes, I think it's important to have classification in your facility model to help you match against the things that you will get from the product resources and so on. And I think it remains the designer's responsibility to make sure that their model is consistent with the scheme that they're applying. And again, I have to just say, you know, we are not choosing a scheme. We think we can support any of the schemes that are being implemented, you know, to a good level of detail. And yes, I mean, in the UK, we have standards that say that if you're using generic information, you must add 30% to the numbers you use. All these things can be handled by this division between the three things. I think that's the answer.
Yes, and we were also thinking, should we split the ideas into smaller chunks? But then we would end up with 80 different ideas files, and we thought it's better to do it this way, because IDEAS has this nice feature that you can say in the specification that if a model has a window, then this window needs to follow this in this specification. But if your model doesn't have a window, you just skip this step. And the same could be applied to electrical system. If you have those elements, they need to have those properties specified. If you don't have it in the model, then you simply just omit it. So that was our approach. And as we said, these ideas can be tweaked to the specific needs, but we want to offer a very universal solution that should work for most of the cases. And we will, once we publish it, of course, we will welcome all of the feedback. We want to confront it with your experiences and improve it, of course. That's not a finalized, complete solution. And hopefully at some point we will agree, but I think it will take some time. Okay, I know there are some more questions, but let's go to the next challenge. This one. Yes.
You want me first to cover?
Well.
Okay, go for it. No, okay, go for it.
Well, if you have a question to this one, because we already covered it partially, so please go ahead.
Okay. So first, what you said, now I really try to simplify on a global level things. So let's say what you said now with IDS, you should talk with Thomas, you know, you should have use cases in a single IDS in the future. Please do that, because then you will not need 80 IDS file, but it will be fully flexible. That's my suggestion in the future to allow this. But go to this specific thing. So we on our teams on two Horizon projects did an analysis like you now presented, and definitely I fully agree. You should never separate files, because that's separate elements, because that's simply not the way. You should not change the design in order to achieve any analysis. That's completely wrong. But there is another very simple way, and certain tools do proper export to IFC. So there is something which is called material properties on the element. And I know you know what we are talking about.
That's one of the long discussion we had, because in most IFC versions that was not really allowed.
But, okay, just
it was a workaround.
I know what we do now from, let's say, one tool you have heard about, Revit. We have two exporters. One is direct IFC, of course, and second one is with all these additional properties, and then integrate in Excel all this. Very simple and straightforward. I hope the guys from that very small company will slightly tweak this IFC export, their IFC export. But there are other tools which already do this properly, and then you don't need to have this calculation, because then the system will do that. And just to mention another, which really surprised me, I believe it's fit for purpose solution, but not long term solution. That what the guys did in Scandinavia. They literally, for every composite wall, created the carbon footprint calculation. So it works now, but the problem is if you just slightly change one layer, you need to, in the database, add the carbon footprint for that composite again, which in a long run, I believe, is not sustainable solution.
Yeah. I think the challenge is to make sure you put in the facility the description of the facility, and in the product data you put a description of the product. And if it's a layered product, there will be things Yes, there is blockwork and brickwork and insulation, but there are also ties and lintels and accessories and so on, which will never be in the facility model. And we shouldn't confuse the material layer sets in IFC, which are primarily to get the graphic representation required. Now, it has evolved from where it started, and now it is containing more and more information, but it is product information that people are then putting in there. And I think we need to manage the distinction very carefully. Okay.
Yes, I think it's now a good time for one of the warmest discussion we had, which is the challenge 6. We can go back to the previous one, but number 5, because it's really touching on what we were discussing already, but there are many ways how we can put the same information into the BIM model. Some of the ways are recommended by the ISO standard, some are recommended by the IFC, some are a common practice, and none of them so far is perfect. Like, we haven't identified any solution that we all agreed on. And here's the list of different approaches we considered. And we are just looking at one property, which is the global warming potential. But usually there are 15, 18 indicators that are listed in declarations. And since declarations are usually PDF or XML, they have a table. The table has rows with indicators and columns with different modules, different stages of the project. But in most IFC models that we looked at, there's always property with only one value. So people don't put tabular values in their models because that's really rarely supported by the software. So we looked at different options. One was to I see my mic was muted. Excuse me, sorry for the online audience. One of the solutions was to use the dedicated connected properties feature from that ISO standard is recommending, but this we didn't find support in any software, and we spoke with software vendors. This is something that would really also confuse users because pairs of properties are not supported by IFC as well. Another approach was really common, which is to just concatenate the name and just put, for example, the GWP underscore A1 to indicate for which module this property belongs to. But it's also not great because this way we end up with many variants of the same property, and that's really not, let's say, consistent throughout different projects that could have different phases, different scope. We looked at possibility to just concatenate the values as a string, but it also needs all of us to follow the same principles. We looked at the IFC list and table, which were desired from the technical perspective, but also not really understood by users and not supported by software. And so far, we haven't reached any conclusions, but we wanted to ask you what's your experience, what's your opinion on how people should capture, if they need to, how should they capture, for example, global warming potential value of their instances of objects in their models. And let's start with this question.
Thank you. Okay. No, I just wanted to ask you if you have checked the guidance of there is an ISO 22057.
Yes, that's the one.
That's the one that
suggests pairs of properties. But in IFC, you cannot have multiple properties with the same name on the same object. So this is not really allowed because you have GWP, and GWP, all of those properties for the same wall in the same property set. So the closest to this was the IFC complex property, which is not found in any software that I know.
No, sorry. So let's say the last solution, which is all the string, it may contains also, a set of parameters that are needed. For give you another example, it's also important that it may be simple, but the year, because even the EPDs or the values has a certain validity, right? So we may be doing an analysis with a value that is today not valid. Okay, it's a reference value, yes,
Mhm.
but maybe it's not the, so
Yeah.
you could potentially add, I don't know, more parameters and have a longer string. I don't know.
That's why we had this one conclusion that was on the previous slide, that we recommend not copy pasting values from the format that is already standardized, but just referencing from which document you are deriving the data, so that people can always look at the source, look at, is it still valid? Has there been any changes? And this way we don't copy paste data that might become at some point no longer up to date. So this is a challenge that we faced for those use cases that require the impact indicators to be captured in the model. Yes?
Okay, sorry again, but just, okay, you really, congratulations, you tackled all the issues our team also faced with, and even on a more complex level, so really congratulations on the work you did. I wanted to tell you, just from a technology software perspective, all these proposals are maybe the easiest one, but from a perspective of database is completely wrong. So this is, all these are workarounds. So and temporarily it's okay. Temporarily also we in our system use one of those solutions in order to have flexibility, and it already works with all solutions, which is great.
May I ask what's the solution that you are following from this list?
We use a property set, and then in a property set in the name, yes, this one, F, and then in a property set name, we create combined property name, which is material and the property, like let's say wood, partition layer, and area. But the only sustainable solution is what now, okay, understood what you said, Nick. Is it material? Is it product? But you need to have a separate domain, which is material property for a single element. So I have for each element, each material in my composite wall, the desired properties like width and area of a.
How would you handle, for example, windows?
Everything will work.
How would you handle windows that have multiple materials that are usually not even models? And it's a simplistic, it's just a model. We are simplifying the geometry just to.
If it's made from wood, let's say you have wood and glass, for example, then you will have attached properties to wood material in it. Could be any property you would look, maybe total volume of wood used and total volume of glass used. And then you will have a two separate, and then the connection with the material database could be, which is exterior, could be external, is direct, and you do all the calculations automatically, and whenever something is changed, everything is sorted out. So this is my opinion, the only fully professionally in terms of architecture of software and database solution which works. Everything else here is, honestly speaking, I mean, if anyone is software developer here, this is completely workaround. I know. No, I'm just. No, but it's no. If you have three materials, how you will sort it out?
We knew.
Could you pass the microphone? No, thanks.
These are based on elements. You click, for example, the window. If you can select the glass separately, you can add it to the glass. But basically, usually you have the window, which is wood and glass. So it's a number. You need to file in the number for A1, A2, A3. And if you only know A1 or only A2 is important, for example, if it's generic, you can just say dash 42 dash if only 42 is important, because it needs to work in every phase of the project. And modelers, we as modelers need to file, we need to add the value. So.
We consulted some vendors that provide LCA software, and they said they will never trust the volume because usually most of the elements that are important are missing. So in case of Windows, people don't model hinges, they don't model the rubber, how do you call it? this insulation, and those are driving the LCA values. And if you don't cover them, and you just look at the wood part of the window and glass, you get a really decent number, but it's not really reflecting the true product.
And this,
Nevertheless, this is not a problem. Any of these solutions, you cannot connect with any external way. You don't have a way how to do that. That's not the solution.
Do you see other options than those?
Yeah, there is very existing option. You have to each element, you can connect an entity which is on material property element subset. So for each material,
yes,
you can have several properties. So you don't need to have them in the even for a window.
Yes,
you have
I hear you. And even if you just do it for a material, let's say you take this timber, the same problem. You don't know, because GWP is not one value. It's a different value for different modules. So you need to either have as many copies of this property as many you have modules, which is one of the solutions we found that the least useful, because we are basically inventing a new property name for each module, and projects have different scopes, so they have different ranges of those modules. That's why we thought this solution is quite common, but this is not really desired.
And which one you suggest?
Well, we had different opinions in the group. I can speak for myself. I like the approach with the PSET, but we consulted people that use Revit, and Revit doesn't allow to have properties with the same name in different PSETs. So that one was kind of like, for practical reasons, we skipped this one for now.
I have some news, which is that at IFC 4.3, you are obliged to support properties with the same name on an object, because door leaf information door leaf information, if you've got 2 doors or 4 doors and all, is now a property set. So I don't know if anyone has checked if Revit is now doing this properly, but actually there is an obligation to do it. So we may have to push the vendors to think about this more carefully. It becomes particularly important if we want to take the results of an LCA analysis and load it back into the model to use your results as a resource going forward. If you do an LCA calculation on one project, you might want to use that as the basis of your baselining for the next project and so on. So we do have to solve this, and we have to solve it in a way that has the flexibility to fit in with the systems that are out there, but they may have to be a little bit more flexible too.
Yeah, you already said that the PSETs were not really considered, or
they were one of the top options.
I like PSETs, no doubt, but still, it's more work to add it as a model. You have to, especially EP sets, you have to create them yourself or be sure that you export them correctly. While just one property where you can add some numbers, it's a lot easier.
Users like those 2 solutions the most because they are the simplest ones.
Yeah, for the usage, I think B and C, and I think I even prefer C above B, but maybe.
When we spoke with software developers, they really like the list option because that's how they want to have it in the database. Really cool as well. Yeah. We have a few minutes left, so let's take a question from Mirberg. And do you want to have some final remarks, Céline? Okay, so let's take 2 last questions, please.
Yes. Just to remember that we are having materials theoretical and that we need to know the real materials spent in the BIM model if we want to have the values, and that almost 50% of carbon are not materials or even more. So if we are going to store values in the BIM model, it's important that we can introduce the values of construction, of transport, and the waste.
Yeah, those are the modules, A1, A4, A5.
In order to improve.
Okay. Yes.
Thank you, Nick, for reminding about property set. Those door lining property set and door panel panel properties. We took that into account of ideas for BIM and BAM. They are already part of it.
Thank you so much. We will share the challenges after the session. We have a few more that are quite interesting from the circularity point of view, like this one. But I would like to give mic to Céline to have some concluding remarks. Thank you so much for the active discussion.
Can I have this one? Thank you. So we really appreciate all your inputs, and we would like to ask you if you can continue providing us your feedback. So the slides will be shared, obviously. There's some challenges that we haven't really covered yet. So if you have any preferred solutions, ideas for solutions, any challenges to add, we really welcome them. So please email me and I will make sure that it will end up in our group's work. And this is a work in progress and we believe it's really important. So please spread the word and join us if you want. Thank you.